So while you are doing the synthetic division for each of these, I will, just to save you some time, I'll tell you what you get when you plug in 1 into the first one, you get 0. Plugging in 3 into the next one, you get 4. And plugging in -2 into the last one gives you 0. If you'd like to check your synthetic division, here's the answer for the first one. Here's the results for the second one. And the third one. Now, which ones are factors? You can tell something's going to be a factor if the remainder is 0. So these ones have a remainder of 0, but this one has a remainder of 4. So we know that the first and the last one are factors of those polynomials. The other thing I got you to do, well, I put up before, was what happens when you plugged in 1, what happens when you plugged in 3, what happens when you plugged in -2, and we got 0, 4, 0. Do you notice a pattern? And the question is, does that always happen? So the pattern is that it seems to have matched with the remainder. The question, does that always happen? The answer is yes. And it's something on the next page. It's called the Remainder Theorem. You can highlight it right here.
Please excuse the interruption. This is Samantha Stoll staff. I'd like to have a staff to meet me today in room B10 at 12 o'clock. I just want to...
Our remainder theorem says that that will always happen. If you have a polynomial and you're dividing by x minus a, if you plug in whatever the opposite sign is of that minus a. So if, for example, if you were dividing by x minus 3, you would plug in positive 3. And whatever you get when you plug that in becomes your remainder. And the reason that happens is straight out of your division statement. Your division statement, which is your polynomial equals dq plus r. And if you know that you're, and I'll do it with our example, if you were dividing by x minus 3, what happens when you plug in 3 for x? Can you see that this would become 0? And anything, when you plug in 3 for x, anything times 0 is still going to be 0, so this is going to disappear, and you're just going to get your remainder that's left. And so this is our remainder theorem, and this is going to be important because if we can find out quickly that our remainder is 0, then that's going to lead to something called the factor theorem. And that's on your next page. We'll highlight it right here as well. The factor theorem says, same thing, if we're thinking about x minus 3, just to use numbers, sometimes numbers are easier to visualize rather than x minus a. If you plugged in 3 into your polynomial and it was equal to 0, that tells you that x minus 3 would be a factor. And this is called the factor theorem. Basically, the factor theorem is just a specific case of the remainder theorem. So now when we want to find a remainder of something, we can do that by either plugging in that value and using the remainder theorem. So if I want to find a remainder, when I divide by x minus 3, I can either plug in 3, or I can still use synthetic or long division to actually figure it out. And in some cases, it might be easier to use synthetic division to find the remainder than the remainder theorem. In other cases, it might be better to use the remainder theorem rather than using synthetic division. So we'll see some of that come up. So it's important that you understand both of them, synthetic division that can get you your remainder, or the remainder theorem by just plugging in a value to get it, because there will be specific questions where one method is easier than another.